To be explaining stars. So, what factors contribute to a star's brightness? Distance, temperature, and size. So, the first thing I'm going to be explaining is distance. As you know, a star's brightness can be very bright or not very bright, but usually they're pretty bright. It just really depends on how near they are or how far they are, or how near you are or how far you are. Because we can see the sun pretty clearly a lot of the time, but that's because the Earth is pretty close, and the sun looks kind of large to us and very bright, but that's because it is nearer to us. But like Pluto, it's not very bright and it looks very small to us, but it is a dwarf planet. But there could be a planet that was huge, so huge, but it looked like a molecule to us because it was so far away and it looked so small. The next thing I'm going to be explaining is temperature. Temperature kind of flip-flops for stars, or the color flip-flops for temperature for stars. So red, bright red is cold, very cold. But on Earth, bright red is very hot. So again, it flip-flops. Dark blue is very, very hot, very, very hot. I think it says it's about 33,000 degrees surface temperature Kelvin. And then the white varying to white yellow is like the main sequence stars. So those are kind of like in the middle, but you can still not touch them because again, it's Kelvin, not Fahrenheit, and it's way too hot. So now I'm going to be explaining size. So I explained this a little bit for distance, but I'll explain it again. So Betelgeuse is the biggest star in the universe, and Sirius and Sirius B are the brightest stars in the universe. But excuse me. I don't know how to explain it. Size, it varies because here, the larger of two stars with the same temperature at the same distance is brighter. So if I had a star that was the size of the sun and then a star that was the size of Earth, they were the same distance and the same temperature. The star that was the size of the sun would be brighter because the size is bigger. So now I'm going to be showing you this chart. Bluish is the hottest. It's above 31,000 degrees Kelvin and 300,000 degrees luminosity. Bluish white is 9,750 to 31,000 degrees Kelvin and 10,000 degrees luminosity. White is 7,100 to 9,750 degrees, and the luminosity is 70. Yellowish white, 5,950. 5,950 degrees, and then 7,100 degrees. And then the luminosity is 6. Yellowish is 5,250 degrees to 5,950 degrees. The luminosity is 1. Orange is 3,950 degrees to 5,950 degrees, and that's 0.4 luminosity. Reddish equals 2,000 to 3,950 degrees, and 0.06 luminosity. Now, this is very hot for us, but very cold for stars. So now, so LeBron and Trina are talking about our sun and other stars. Trina argues about that the sun is much larger than the other stars in the sky. She also explains that most of the other stars are about the same size as each other and the same distances from Earth. LeBron disagrees. He explains that the sun looks larger than the other stars because it is closer. He also argues that the other stars vary a great deal in size and distance from Earth. Who is correct? LeBron is correct because the sun looks brighter and bigger because it is closer than other planets. And stars vary in size completely. Nothing is no star is ever gonna be the same size. Sorry. They're always gonna vary in size. And they're all gonna vary in brightness. Thank you.